Podcast 2 is going to discuss parallel processing. The goals give you a definition of parallel processing, applications, and an assignment. A working definition of parallel processing is the ability to assimilate and coordinate various internal and external stimuli and information quickly and efficiently. It is also known as situational awareness, in the zone, and streaming. A model of parallel processing based on information processing is that we can parallel information. For example, in the vision system, center and periphery, or in the brain, the cognitive and non-cognitive. So we can use both channels at the same time, which is the most efficient, as will be described. A flip-flop, taking from computer language, that someone can go back and forth from one channel to the other. Parvo means that one is a serial processor only for central information, cognitive information, and magno is for those who process also serially, but in the periphery or non-cognitively. Here's a graphic to show that both the eye and the brain have these different channels, and there's many different interactions among them. Here's just another graphic to illustrate the relationship of the different levels of the model. This is a two-dimensional model. If we now consider informational space, a line, a plane, and a sphere all have an infinite set of points. However, as we can see from the next screen, there are different types of infinite sets. For example, a line and a plane have a convergent set of infinite points, while a sphere has a divergent set of infinite points. And these are some formulas for those who are interested in that area. Here's a three-dimensional graphic showing that parallel processing is like a sphere, a flip-flop is like a plane, and the parvo and magno are like a line. A line is one-dimensional by its length. A plane is two-dimensional, and for a circular plane is a circle, pi r square. And for a sphere, it's 4/3 pi r cubed. So the next slide is going to show how that relates to how much information we can process per unit time. So as a serial processor, analogous to the line, we see that we're going to just go from 1 to 2 to 3 to 4 linearly in our processing of information. In a plane, we're going to use a square function, and in the sphere, the parallel processing, we use the cube function, and we see how much more information we can take in per unit time by being a parallel processor as opposed to the other two types of processing. As an assignment, listen to a news report and read a book at the same time. Can you do it? What happens? If you have any questions or comments, please feel free to contact me at the email address listed here.